Okay, so let's look at the idea of one of the most important topics in O-level chemistry, and that is organic chemistry. Now, in organic chemistry, you already might know the idea of what compounds are, and basically, chemistry is something that deals entirely with organic compounds. Now, what are organic compounds? You already know what our compounds are, okay? But organic compounds, you can say, are compounds that has carbon which is bonded with either oxygen, nitrogen, hydrogen, and fluorine, and it can also be bromine or any other atom as well. So this is going to be entirely purely based on a carbon that will be either bonded to a oxygen, nitrogen, hydrogen, or to a chlorine or a bromine or any other thing else. The most important part is the carbon. The carbon has to be consistent to the fact of the matter is that carbon, we also call organic chemistry as carbon chemistry. Okay, I bet you didn't know that. Now you do. Okay, so that's the idea of what are organic compounds. Now, before jumping entirely to the topic, one very important thing is what are or trying to understand what are valencies. Now, you already might know the idea of what are valencies. I'm assuming if you have studied the previous chapter, you know what valencies are. Why is it important in organic chemistry? Because organic chemistry will be using carbon and all of the other mentioned atoms that I just mentioned above. So we need to understand how many bonds are they going to be making in the compounds. Okay, so let's say we have a carbon. Now carbon we know has the electronic configuration of, basically it has 14 electrons, and that means it has an electronic configuration of 2, 8, and 4. Okay, so now how do you judge? So if I look at this carbon atom, in its outermost shell it has 4 electrons. Okay, so if I draw the outermost shell, it's going to have 4 electrons. 1, 2, 3, and 4. And now to basically complete its octet, now you should know the idea that every atom that is out there, except for the noble gases, because they are unreactive and stable, all of these elements, all of these compounds are trying to complete their octet. Okay, so let's say we talk about a sodium atom, for example, right? So the sodium has an electronic configuration of 2, 8, and 1. So to complete its octet, what it's going to do, it's going to lose this electron from its outermost shell, and hence it gets a positive charge. Okay, that's the idea. Now, because this is a metal, and metal and non-metal are usually involved in the bonding that we call as the ionic bonding. This here, when we talk about carbon, when you talk about a non-metal being bonded to another non-metal, because in organic chemistry you'll be talking about carbon bonded to an hydrogen, oxygen, all of these other atoms are also non-metals. So when we're talking about when we're talking about non-metals being bonded to other non-metals, we will be talking about covalent bonding. And covalent bonding involves sharing of electrons, not losing or gaining of electrons, but sharing of electrons. Okay. So here the idea is, now the carbon in its outermost shell has 4 electrons. That means it's going to be sharing 4 electrons. And just by looking at that idea, because it shares 4 electrons, you should know that it's only going to be making 4 bonds. So for the entire organic chemistry, you should know that carbon is going to be making 4 bonds. Let's talk about oxygen. Now oxygen has 16 electrons. So 16 electrons mean that it's going to have the electronic configuration of 2, 8, and 6. Now looking at the outer shell, it has 6 electrons. It needs 2 to complete its outermost shell. Now, because it is a covalent bond, it's going to be sharing electrons, right? So because it needs 2 electrons, so it's going to be making how many bonds? 2 bonds. Same goes for nitrogen. Nitrogen has 15 electrons. Yeah, nitrogen has 15 electrons. So the electronic configuration is 2, 8, 5. So it needs how many, or how many electrons does it need in the outermost shell? It needs 3. So it shares 3 electrons, and that corresponds to the idea of nitrogen making 3 bonds. And there is one more that we need to do, and that is hydrogen. Okay. Now hydrogen has only a single electron, and we know if it has a single electron, that it's only going to be making single one single bond. And the idea is, how does this is actually work? So let's say I talked about carbon, right? I talked about that carbon has a tendency to share 4 electrons, meaning it's going to be making 4 bonds. Okay, so 4 bonds with carbon. Now I'm just going to make a molecule so that you have the idea how does the sharing of electron actually happen. So let's take a molecule. Let's take a CH4 molecule. Okay, now here you can see you have got one carbon. Okay, and you have 4 hydrogens. One carbon, 4 hydrogens. If I were to draw a dot and cross diagram for that, so let's say you've got a carbon in the middle. Okay, and in the dot and cross diagram you only you only draw the outermost shell. So because the carbon has the electronic configuration of 2, 8 and 4, in its outermost shell it's going to have 4 electrons. 4 electrons, meaning to complete the outermost shell it needs 4 more. Okay, it needs 4 more. And now because hydrogen is a non-metal, carbon is a non-metal, it's going to be covalently bonded. Covalently bonding means sharing of electrons. Okay, so now there are 4 hydrogens and one hydrogen makes one single bond. So 4 hydrogens are going to be making 4 bonds. So now here you have one one electron of carbon. Here you have the second electron of carbon. Here you have the third electron of carbon and the fourth electron of carbon. So these are the what? These are the electrons of carbon. Now, how does the sharing happen? So here, if I draw the outermost shell for hydrogen, hydrogen its first shell is also its outermost shell because it only has one electron. So here there is one hydrogen, and this cross I'll just draw it with another color. So this cross here represents the electron from hydrogen. Same goes here. So if I draw a hydrogen molecule here, and then this cross represents the electron from hydrogen. Same here, and same here as well. Now you see, carbon had 4 in its outer shell. Okay, and then the 4 hydrogens bonded. So the 4 hydrogens that we had, each of them had one single electron to share, and they shared that one electron. And by that, what happened? Hydrogen achieved Each atom of hydrogen achieved their stable configuration, which is of the 2 electrons. So the first shell is this is basically carbon completing its what do you call that? I forgot the name. Yeah, duplet. This is basically each hydrogen completing its duplet electronic configuration, and carbon completing its octet electronic configuration. So now carbon has 8 electrons shared, 4 of its own, 4 shared by hydrogen, and each hydrogen atom has 2 electrons in their outermost shell or in their first shell, and they complete their duplet configuration. So that is the idea, and that is how you should know how many bonds all of these are going to make. So, and the most common of all these were going to be, you're going to be studying a lot about hydrogen. There will be a lot of oxygen as well, and nitrogen. Yeah, it's going to be there, but might not be a lot. So that is the idea of the valencies and why is it important, and a little intro to organic chemistry. Okay.